Hey everyone, this video is going to take a look at the free response question number 3 from the 2018 AP Stats exam. So let's take a look at it. Approximately 3.5% of all children born in a certain region are from multiple births, that is, twins, triplets, etc. Of the children born in the region who are from multiple births, 22% are left-handed. Of the children born in the region who are from single births, 11% are left-handed. What is the probability that a randomly selected child born in the region is left-handed? Okay, one of the biggest things that students struggle with on the AP exam, I think, is probability, and the hardest part really is just getting started. So it's really important that you drill the different types of strategies they can use for problems like this. And really, with my classes, I try to do everything in either a two-way table or really a tree diagram, which you could do this problem with a two-way table, but then you're getting into a lot of the formulas, which is kind of unnecessary. I think the best way to go about this problem would be a tree diagram. Okay, so we would start this because the first thing they tell us is 3.5% of all children born in a certain region are from multiple births. So I'm going to call this MB, multiple births, SB for single births. And they give us that number 3.5%, so I'll just convert that to a decimal to make that 0.035. And then we know the complement of that 1 minus 0.035 would be the probability of a single birth, which is 0.965. Okay, so why was it a good idea to do a tree diagram here? It's because from there, they're giving us a conditional probability, which the second step in a tree diagram is always a conditional probability. So of the children born who are from multiple births, so of this 3.5% selected, 22% are left-handed. So we'll do LH for left-handed, RH for right-handed. So 22% are left-handed, and that means the remaining 78% would be right-handed. And then they give us information about the children born in single birth. Same idea, 11% of them are left-handed. Once again, that's a conditional probability. So 11%, complement is 89%. This 11 would be left-handed. This 89 would be right-handed. And then the beautiful thing about the tree diagrams is to get these probabilities, you multiply down the branches. So just to save time on the AP exam, I'm not going to multiply out all these branches right this second, but I'm going to see what branches we're interested in. So they want to know what's the probability that a randomly selected child born in the region is left-handed. So I'm just going to multiply for right now. I might have to go back and do the other ones, but just for now, to save time, I'm just going to multiply the branches that deal with left-handed. So 0.035 times 0.22 is equal to 0.0077, and then down here 0.965 times 0.11 will give us 0.10615, which the nice thing about the AP Stats exam is if you wanted to round this, I'm sure you could and you can get away with it, but I'm just going to leave it as is to be exactly correct. Okay, now that isn't your answer. We wouldn't leave it like that, but we would say the probability of left-handed would be those two probabilities added together, 0.0077 plus 0.10615. And that'll come out to be 0.11385. Okay, so I think everything looks good for part A. Let's take a look at part B. Okay, what is the probability that a randomly selected child born in this region is from multiple births, given that the child selected is left-handed? So I teach my students anytime they see the words given that, let's rewrite it with the proper notation. Remember, given that is a giveaway for a conditional probability. So we're still looking for the probability of a multiple birth child given that they are left-handed. And usually when you're given these conditional probabilities like that, you're going to have to take a look at your formulas. Now, the nice thing about the formula sheets that were updated this particular year is they're pretty organized, and we have this conditional probability formula right here that they can refer to. So you don't even have to memorize this. Okay, so this probability will be equal to the probability of multiple birth and left-handed divided by the probability of left-handed. And the nice thing is it's all dealing with left-handed, not right-handed, and we already crunched some of these numbers. So remember, the probability of multiple birth and left-handed is what we calculated up here, 0.0077. And then the probability of left-handed, we actually found that in part A, so 0.11385. So we want to divide those to get the answer of, now this is a really long decimal, so I'll just go 4 decimal places, 0.0676. Okay. So the tree diagram is still very helpful with part B. Okay, now part C is not very different from part A and part B, but definitely different. So let's read through part C. A random sample of 20 children born in the region will be selected. So what is the probability that the sample will have at least 3 children who are left-handed? So when I see this, I think 2 things. I think, is this a sampling distribution problem? Which in this case it's not, because we're not talking about means, we're not talking about standard deviations or anything like that. And the other thing I think is it binomial? The one thing that makes us think binomial is there a set number of trials? In this case, we are taking a sample of 20 students. So let's go through binomial and how we check. We use the acronym BINS. So is it binary? Meaning, is there a clear success and failure? So success would be, since we're looking for the probability of left-handed, would be left-handed. Failure would be right-handed. Sure. Okay. Are trials independent? In this case, yes, because the first child being left-handed has nothing to do with the next child being left-handed. Okay, I first select my first kid, Joey, he's left-handed. That has no effect on whether Michael is left-handed or not. Okay, N, is there a set number of trials? Yeah, there are. 20. And we have the same probability of success. Yes, that should be the answer we got from part A, probability of left-handed. Okay, so yes, it's 0.11385. Okay, so this is definitely a binomial situation. Okay, so let's take a look at how we would set this. I'm just going to because I like to define my variable x for binomial. X just represents the number of left-handed students. So what we're really looking for is what's the probability that X, and when they say at least three children who are left-handed, they mean 3 or more. Okay, so what's the probability that X is greater than or equal to 3? Okay, now when we do binomial distributions in AP Stats, the easiest way to do it is with the graphing calculators. Now the thing with the graphing calculators is when you do a binomCDF, which is a binomial cumulative distribution, it only counts up from 0 up to the number we're interested in. It wouldn't count from 3 up to 20. So we actually have to take like the inverse of this, the exact opposite, and subtract it from 1. Okay, so what I mean by that is the probability that X is greater than or equal to 3 is the same exact thing as 1 minus the probability that X is less than or equal to 2. Okay, it's the complement. And what we'd want to do in our calculator is 1 minus binomCDF. Remember, we use PDF when X is an exact number, like what's the probability that we end up with exactly 5 left-handed children? That would be binomPDF. binomCDF is a cumulative figure. So when we do binomCDF, it's going to ask for 3 values. It wants the number of trials, which is 20, and we want to define it as n equals 20. They want the probability of success, so that would be the answer we got in part A, probability of left-handedness, so 11385, and they want to know how many successes we're looking at, which in this case we're looking at 2. Now remember, binomCDF isn't going to calculate just 2 left-handed students. It's going to be the summation of 0 left-handed students plus 1 left-handed student plus 2 left-handed students, and that's going to stop there too. And then we're taking the complement by doing 1 minus. So I wish I had the calculator on my computer, I'd show you, but really this comes out to be, let's get the decimal, let me just type this into my calculator real quick. .5979, we'll say. And then we just subtract 1 minus that, and we get an answer of 0.4021. And I probably should throw these equal signs out here in front. Okay, so once again, answering here, what's the probability that out of our sample of 20 we have at least 3 children who are left-handed? There's about a 40% chance of that happening. And that should be the problem, and I think that would be enough to get you a 4 out of 4 on this question. Okay, so if you have any comments, feel free to leave those in the video below. Any advice or anything I could do better here, please feel free to mention that, and look forward to making more of these.